Hello students, in this video we are going to discuss on ellipse. In the last video we have learned circle and parabola. So what is ellipse? Ellipse is the path traced by a point which moves in a plane in such a way that sum of its distance from two fixed points in the plane is a constant. You can see in the diagram F1 and F2 there are 2 points, they are fixed point and they are called foci. Foci is the plural form of focus. So F1 is a focus, another focus is F2. P is any point, say the coordinates are x, y, following a particular criteria like the sum of the distance from F1 and F2 always gives the constant result. So following this condition, the locus of the point P is giving ellipse. We can define ellipse in another way, like an ellipse is the locus of a point in a plane which moves in the plane in such a way that the ratio of its distance from the fixed point, we know it's called focus, in the same plane to its distance from a fixed straight line called directrix is always constant, and the result always less than unity, that means less than 1. So what is this? Say this is a fixed line, and the fixed line we know it's called directrix. If be a fixed point, it's called focus. So now P be any point with coordinate x, y. Now the distance of PF and the perpendicular distance from P to the fixed line PM, the ratio always less than 1. So we can write here PF by PM. This ratio is always constant denoted by a particular letter E, which is actually eccentricity of ellipse. And when this result eccentricity is less than 1, then the locus of point P gives ellipse. There are some terms related to an ellipse. What are they? They are center of the ellipse, axis of the ellipse, vertices of an ellipse, eccentricity of an ellipse. So what is center of the ellipse? The midpoint of the line segment joining F1 and F2. F1 and F2, they are foci. So center is lying just at the middle of F1, F2. So we can say OF1 equals to OF2. Now what is axis of the ellipse? Axis of the ellipse, there are two types of axis of the ellipse. One is major axis. Another is minor axis. So what is major axis? This is the line segment through the foci of an ellipse. See here, AB is the line segment through the foci of an ellipse with its end point A and B lies on the ellipse. Now this AB line is called the major axis. And what is minor axis? Minor axis is the axis which should be perpendicular to the major axis and passing through the center of the ellipse. So here CD, where C and D also lying on the ellipse, and CD line is perpendicular to the major axis and passing through center. So CD is minor axis. What is the vertices of the ellipse? The vertices of the ellipse are the end points of the major axis of an ellipse, is the vertices of the ellipse. So here A and B, these 2 points are vertices of the ellipse. Now come to an important terms, which is eccentricity of an ellipse. So here if we consider this is C, OF2 and OF1, the distance between these 2 points is C, and the length of the major axis is twice A, length of the major axis, then the ratio C by A is always constant, and which is called eccentricity of ellipse. We have already discussed about the result of this constant, which is less than 1. Then the eccentricity will be of ellipse. Now we are going to discuss an important result, which is a square minus c square equals to b square. Let's see what are given. AB, which is major axis, so length of the major axis is given twice A. Major axis AB is given twice A. So obviously from point A to B, this length is twice A. So half of the major axis should be A unit. So here we are getting that OB is equals to A. Here it is given F1, F2 equals to twice C. Generally, OF1 equals to OF2, which will be giving C. Here CD is the minor axis, whose length is given twice B. So if twice B is the length, half of the minor axis is B. Now what is the length of CF1? The length should be root over B square plus C square. Similarly, the length of CF2 is equals to B square plus C square. Because this angle is 90 degree and these are right angle triangle, we can easily find out the length of CF1 and CF2. Since B and C, these 2 points lying on the ellipse, so sum of the distance of the points from the foci F1 and F2 must be constant. We can write from that criteria BF1 plus BF2 is equals to constant, and which will be the same result of CF1 plus CF2. So let's find out this all measurement. CF1 and CF2 already we found the values, so we can add them. We'll be getting 2 root over b square plus c square. And what about BF1? BF1 can be written from the figure you can see. We can write OF1 plus OB, and BF2 we can write as OB minus OF2. So that implies OF1, what is the measurement of OF1? That is C. And OB, obviously half of the major axis, A unit, OB is A, and OF2 is also C, which is 2 root over b square plus c square. So by calculating, we are getting twice A equals to twice root over b square plus c square. Cancelling and squaring both sides, we are getting a square equals to b square plus c square. That implies we are getting our answer. The relation a square minus c square is equals to b square. Now we know the eccentricity. Eccentricity E is equals to C by A. And we have already got the value of C, which is root over a square minus b square. So if we put the value over here, root over a square minus b square by A, so it would be the eccentricity of ellipse. Now we will be discussing on the equation of the ellipse in standard form. The equation of the ellipse in standard form is x square by a square plus y square by b square equals to 1, where the major axis must be greater than the minor axis. That's why it's called major axis. Here, if we give the name AB, which is major axis, should be more than or greater than the length of minor axis. Then the ellipse will be the horizontal ellipse. Now let's see the different coordinates, the coordinates of the different points. If we take the origin as center of the ellipse, so x-axis will be considered as the axis of major axis, and y-axis will be considered as minor axis. So equation of major axis is y equals to 0. Equation of minor axis is x equals to 0. Coordinate of foci, that is f1, the coordinate we considered here a e comma 0, and this is minus a e comma 0. The coordinate of the endpoints of the major axis, which are vertices. The coordinate of point A should be minus a comma 0 and point B should be a comma 0. The coordinate of the end points of the minor axis, that is C and D, since this length is B, so obviously the coordinate of point C should be 0 comma B and the coordinate of D should be 0 comma minus B. Now what is the equation of the directrix? The equation of the directrix should be x equals to a by e, and the equation of other directrix is x equals to minus a by e. So equation of directrix is x equals to a by e and x equals to minus a by e. If we draw the perpendicular line passing through focus, this is a chord, and why this is called special type of chord? Because this chord of the ellipse, which passing through the point F1 and perpendicular to the axis, major axis, and this is called the latus rectum. So length of the latus rectum is equals to 2b square by a, and we already taken origin at the center of the ellipse. Here is the other form of ellipse where the major axis is taken along y-axis and minor axis is taken along x-axis. Equation of the ellipse is same as before, like x square by a square plus y square by b square equals to 1. But here a is less than b. Why? Because we have taken major axis along y-axis, so that's why b is larger than a. Now we will discuss on the different equations of the various axes as well as the coordinate of the different points and the equation of directrices. Since we have taken the origin as a center of the ellipse, so the center of the ellipse is 0, 0 here. The end of the major axis lying on y-axis, so that's why the coordinates are 0 comma b and 0 comma minus b. And what are the coordinates of the endpoints of major axis? It should be a comma 0 and minus a comma 0. So we can see from here that is length of major axis is equals to twice b and length of minor axis is equals to twice a. Equation of major axis is x equals to 0 and equation of minor axis is y equals to 0. Next, the directrices. The equation of the directrices are, one is y equals to, here this is y equals to b by e, and here y equals to minus b by e. Where e is the eccentricity. So eccentricity is here, that root over 1 minus a square by b square. Always remember the general form of eccentricity, the formula of eccentricity, that is root over 1 minus length of minor axis divided by length of major axis whole square. The next is coordinate of foci. The f1 coordinate of f1 is here be 0 comma be, since it's lying on y-axis, and here 0 comma minus be. One problem has been chosen. We have to find out the length of major and minor axis, coordinate of foci, and vertices and eccentricity of the given ellipse. So the ellipse is not in the form standard form, so you have to convert it into standard form. So let's start. Equation of the ellipse. (16x square plus 25y square equals to 400. We have to keep it into the form x square by a square plus y square by b square equals to 1. So we have to make right side 1. For that purpose, we need to divide both sides by 400. So that is equals to 1. After calculating, cancelling 400 by 16. So we are getting here 25 plus, and cancelling 400 by 25, we are getting y square by 16 equals to 1. And one thing that you are seeing, that 25 is greater than 16. So if we compare this equation, this is the form of, we must say, this is the form of x square by a square plus y square by b square equals to 1. Where a square means 25 and b square is 16. So that is a gives 5 and b is 4. We should take only the positive value because a and b, actually these are the half of the length of major and minor axis. So clearly we are getting a greater than b. So therefore we can say from here the major axis is along x-axis and minor axis is along y-axis. So equation of major axis should be y equals to 0, and equation of minor axis should be x equals to 0. Now the length of major axis should be twice a. That means 2 into 5, it's 10 units, and length of minor axis should be twice b, means 2 into 4, it's 8 units. Again, we have to find out the coordinate of the vertices, foci. So the coordinate of foci are, we know the coordinate of foci are AE plus minus A comma 0, better to say. So we need to find out the eccentricity first. Eccentricity E is equals to, we know, root over 1 minus b square by a square. So square root of 1 minus 16 by 25, it's giving 3 by 5. So we have got the eccentricity. So once we put over here, we can get the vertices, the coordinate of the foci. So it's plus minus a, means 5 into 3 by 5 comma 0, that is plus minus 3 comma 0. What are the coordinate of the vertices? Coordinate of vertices, we know this is plus minus a comma 0, so that is here plus minus 5 comma 0. Now again we have to find out the equation of ellipse whose center is at origin, and foci are given plus minus 1 comma 0 and eccentricity is half. So foci means we should consider it here f1 and f2. The coordinates are 1 comma 0 and minus 1 comma 0. Eccentricity is half and center at origin 0 0. So obviously the major axis will be x-axis and minor will be y-axis. So we can consider here as f1 f2 as 2, because this distance is 1 unit and this distance is also 1 unit. So f1 and f2, the distance is 2 unit. Let 2a and 2b be the length of the major and minor axis of the required ellipse. With eccentricity E. So we should write here as F1 F2 is equals to twice AE. Why? Because according to the rule, we know the coordinate is minus AE comma 0 minus AE comma 0, and here is plus AE comma 0. So the distance between F1 F2 is 2AE. So that implies we have already got here 2. If we equate them, we are getting AE equals to 2, AE equals to 1, and we have the eccentricity half. So from here we are getting the value A is equals to 2. We are getting the value A equals to 2. So now let any point P on the ellipse whose coordinate is x comma y. So let P x comma y be any point on the ellipse. So here F1 P plus F2 P must be equals twice A. So that implies F1 P means square root of, you must apply the distance formula, and that should be x plus 1 whole square plus y square plus root over x minus 1 whole square plus y square, that is equals to 2 into the value of A is 2. Now keeping the terms, this term to left side and taking the other term to right side, then we have to square in both sides. We have to do the squaring in both sides. So once we do the squaring in both sides, it should be x plus 1 whole square plus y square, and right side should be a minus b whole square. So a square plus b square minus 2ab. So it will be 8 root over x plus 1 whole square plus y square. So now taking this term again to left side and calculating, we are getting over here minus 4x equals to right side only 8 root over x plus 1 whole square plus y square. 16 minus, it should be 16 minus 8. So that implies x plus 4 equals to 2 into root over x plus 1 whole square plus y square. Again, we are getting from here, as doing squaring in both sides, this equals to 4 into x plus 1 whole square plus y square. So taking all terms to left side, we are getting 3x square plus 4y square minus 12, that is equals to 0, and which is the required equation of the ellipse. Now we are going to discuss hyperbola, the last part of conic section. What is hyperbola? It is the set of all points in a plane, the difference of whose distance from two fixed points in the plane is a constant. So here you can say this is a hyperbola whose axis along x-axis. I'll be coming later about the different type of axis. Now see 2 points f1 and f2. These are fixed points which are called foci that we have learned in the discussion of ellipse. So now any point P which maintain a distance pf1 and pf2 following a particular criteria, like the difference between these distances always be constant. So the locus of point P will be giving us the hyperbola. There are few terms related to a hyperbola, like center of the hyperbola. What is center of the hyperbola? Here O is the center of the hyperbola. That means the midpoint of the joining line f1 and f2 is called the center of the hyperbola. So f1o and f2o are equal. Now axis of the parabola. There are two types of axis. One is transverse axis, and second one is conjugate axis. So what is transverse axis? Transverse axis is x prime. Here this is the transverse axis which is passing through the foci of the hyperbola is the transverse axis. And what is conjugate axis? Conjugate axis is the perpendicular line or perpendicular axis to the transverse axis and passing through the center of the hyperbola. What is vertices of hyperbola? The points A and B are called the vertices of the hyperbola, where the curves meet the joining line of the foci. Like here you can see the curve meets f1, f2, the joining line of the foci at A and B. So they are called the vertices of the hyperbola. What is the length of transverse axis? The transverse axis we already came to know, it's passing through the foci. So the length of transverse axis should be AB is the length of transverse axis. Eccentricity of hyperbola. Eccentricity is denoted by E, and that is equals to square root of a square plus b square by a square. What is the lattice rectum? Lattice rectum of hyperbola means a chord of the hyperbola which passing through the focus and perpendicular to the transverse axis. So there should have two chords which passing through the foci and perpendicular to the transverse axis. So here if I give the name like PQ, RS. So PQ and RS are the latus rectum. And the length of latus rectum is equals to 2b square by a. One more thing is directrix of hyperbola. So there should have two directrix. If I give the name as LM, MR, NR. So LM and NR, these are two directrices. The equation of the directrices are x equals to a by e and x equals to minus a by e. And here it is x equals to minus a by e. Obviously, the coordinate of the foot of the directrices should have like this point should be a by e comma 0 and the foot of this directrix should be minus a by e comma 0. There are two types of hyperbola. One is horizontal hyperbola, another is vertical hyperbola. Horizontal hyperbola, when the transverse axis of hyperbola along x-axis is called the horizontal hyperbola, and when the transverse axis of the hyperbola along y-axis, then it's called the vertical hyperbola. The standard form of hyperbola is x square by a square minus y square by b square equals to 1, such that b square equals to a square into e square minus 1. Now let me discuss on the coordinates of different points of these two types of hyperbola, as well as the equation of the directrices and axis of the hyperbola. So we have already learned that A, B are the vertices of the hyperbola. So coordinates of the vertices are plus minus a comma 0. Then coordinate of center, we are considering the center at the origin is 0 0. Coordinate of foci are plus minus c0, or we can write here plus minus ae comma 0. Since the foci lies on x-axis, that's why the y coordinates should be 0. The next is equation of transverse axis. is y equals to 0. Equation of conjugate axis is x equals to 0. Equation of directrices are x equals to plus minus a by e. So the coordinates of the foot of the directrices should be plus minus a by e comma 0. So this is the coordinate of foot of the directrices. Now the length of the latus rectum, already we came to know about the latus rectum. Latus rectum is the chord which is perpendicular to the transverse axis and passing through the foci of the hyperbola, and its length is 2b square by a. And what about the eccentricity? Eccentricity E equals to root over a square plus b square by a square, or we can say by a. So these all coordinates and equation is of are of horizontal hyperbola. Now let we discuss on the different points of vertical hyperbola and the equations of the axis directrices of the vertical hyperbola. So the standard form of the vertical hyperbola is minus x square by a square plus y square by b square equals to 1. This vertical hyperbola, also called conjugate hyperbola. Since its axis is along y-axis, transverse axis is along y-axis, so that's why the foci will be lying on y-axis. So what would be the coordinate of its foci? It should be 0 comma plus minus be. Then coordinate of vertices 0 comma plus minus b. Length of transverse axis that is equals to twice b, and length of conjugate axis is twice a. Now come to the equation of directrix. So equation of directrices are y equals to plus minus b by e. So foot of the directrices are 0 comma plus minus b by e. What is the eccentricity now? Eccentricity E is equals to square root of b square plus a square by b square, or we can write here the root over b square plus a square by b. Length of latus rectum, the chord which is perpendicular to the axis of the hyperbola, to the transverse axis of the hyperbola and passing through the foci. This is the latus rectum, and the length of latus rectum should be 2b square, 2a square by b for conjugate hyperbola. Obviously here equation of the transverse axis should be x equals to 0, and equation of the conjugate axis should be y equals to 0. I have chosen one problem where we have to find out the equation of the hyperbola whose directrix is given, focus is given, and eccentricity is given. So there is another definition of hyperbola where we can take a fixed line which is called directrix, and a fixed point which is called focus. Now any point on the curve P with coordinate x comma y, if we take the distance and draw the perpendicular to the fixed line, then the ratio of these two distances like PM, PF by PM, that is equals to E, eccentricity of the curve, and when this eccentricity is less than the unity, then the locus of the point P gives a hyperbola. So now we have to find out the equation of hyperbola where direct is given 2x plus y equals to 1. The focus is given 1 comma 2. Even the eccentricity is also given root 3. So we have to write here, let P be any point on hyperbola. Therefore, we can say that PF by PF by PM equals to E, which implies PF equals to E into PM. Now PF means distance between these 2 points. It's x minus 1 whole square plus y minus 2 whole square equals to the value of E root 3, and PM, the perpendicular distance, which is 2x plus y minus 1 divided by 2 square plus 1 square. Now squaring in both sides, we have x minus 1 whole square plus y minus 2 whole square equals to 3 into 2x plus y minus 1 whole square by, it will be 5. So now if we expand it, we'll be getting 5x square If we expand and take to another side, multiplying by 5, we'll be getting 5x squared plus 5y squared minus 10x minus 20y plus 25 equals to 3 into, expanding it, 4x squared plus y squared plus 1 plus 4xy minus 4x minus 2y, taking all the terms in one side, and after calculating we'll be getting 7x square minus 2y square plus 12xy minus 2x plus 14y minus 22 equals to 0. This is the required equation of hyperbola. Here is another problem. Find the equation of hyperbola. Refer to its principal axis as axis of coordinates when vertex at plus minus 5, 0 and foci at 7, 0. So we can see here plus minus 5, 0 is the vertex. That means it's lying on x-axis. So we must write here, since the vertices lie on x-axis, so let the equation of hyperbola be x square by a square minus y square by b square equals to 1. Now what is given? The coordinates of the vertices. The coordinates of its vertices and foci are, we know it's plus minus a comma 0 and plus minus ae comma 0 respectively. So we can say from here a should be 5 and ae should be 7. So by putting the value of a, we can get e is 7 by 5. So now we have to find out the value of b square or b, then we can formulate the equation. So now b squared equals to a square into e square minus 1. We know this relation. We have to put the values of a and b over here. So we are getting here 25 by 4 into 49 by 25 minus 1. After calculating, we'll be getting here 24. Now, if we give the name of the required equation is 1, so from 1 we can say equation of hyperbola x square by a square, that is 25, minus y square by b square, that is 24, equals to 1, which is the required equation of hyperbola. The problem said us the foci of the hyperbola coincide with the foci of the ellipse given. Find the equation of the hyperbola if its eccentricity is 2. So here foci of the hyperbola is coincide with the foci of the ellipse. So we need to find out the foci of the ellipse first. So the equation of ellipse is of the form x square by a square plus y square by b square equals to 1, where a square is 25 and b square is equals to 9. So if E be the eccentricity of the ellipse, so let E be the eccentricity of ellipse. So therefore E equals to square root of 1 minus b square by a square. This is the rule to find out the eccentricity when A and B are known. So 1 minus 9 by 25, it's giving 4 by 5. So we found already the eccentricity of ellipse. Now what would be the foci of ellipse? Therefore the coordinates of foci of ellipse are, it should be plus minus a comma 0, that is plus minus ae, that means here a means already we have got 5, e means 4 by 5 comma 0, that is we are getting plus minus 4 comma 0. Now let E prime be the eccentricity of hyperbola. Hyperbola, we can write the equation also as x square by a square minus y square by b square equals to 1. So we can say here E prime must be equals to 4, because the coordinate of foci of hyperbola is plus minus a prime e prime comma 0. So that is equals to 4. We can get from here, it must be a prime e prime equals to 4. That imply 2 twice a prime equals to 4 and a prime equals to 2. Also b prime square, we know the relation is e prime square minus 1, which implies b prime square equals to 4 into putting the values of a and e, it's giving 12. So once we get the value of b prime and a prime, we can write the equation of the hyperbola. So therefore the required equation of hyperbola is x square by a square. A square means 4 minus y square by b square. B square means 12. We have that is equals to 1. Just we are putting the value of a prime and b prime over here.